I'd like to welcome to the stage Prasad. He'll be presenting Shaping the Future of BGP Observability, BMP Evolution at IETF. It's the first time speaking for him today, so please give him a warm welcome, and it's a pleasure to have him here.
Thank you. Right, thank you. Good afternoon. I know it's the first session right after lunch. I hope I can make it interesting for you guys. Myself, Paolo, and Thomas worked on this deck together. They couldn't be here. I'm presenting on all of our behalf. All right. This is the broad agenda for today. The section 1 and 2 is mostly introduction to BMP. BMP at IETF started maybe 10-15 years back. So most of the work which is called out in 1 and 2 is sort of introductory. What happened at what happened in the BMP world in the first 10 years. And then since then, maybe in the last 2 to 3 years, is all the stuff in 3, 4, 5, and 6. It's kind of unbelievable, but almost every other month we get a new draft. We have around 15 drafts at IETF which have come up in the BMP area in the last couple of years. So there's a lot happening. It just tells us that operators want to get done, use BMP for a lot of things. They've played around with the 1 and 2 for the first 5 years or so, and then they're figuring out that there were a lot of gaps, and they're trying to address those gaps coming to IETF and asking for new use cases and standardization. All right, so let's get going. Before I get started, I just wanted to get a pulse of how many of you are familiar with BMP? Maybe if I could have a show of hands. All right, how many of you are already using BMP in your networks? All right, okay. So I think there is enough of you who are new to BMP, so maybe I can spend a bit of time going over the use cases and the introductory stuff. These are some things which network operators want to do. I mean, this is just some of the things I listed, but there's way more. Essentially, they want to have a looking glass into BGP. So what's happening with the routes, what's happening with peering, and then if something is in data plane, it's not in data plane, is it because of is it a BGP related route? It's not a BGP related route. So that's your standard observability. So this is something operators want. They also want to account for traffic volume. Either it is for observability reasons or it's for commercial reasons. And then off late, there's quite a lot of interest in getting sort of alerts from the routers. It's not just a stream of routes or paths from the routers, but they also want to know if there is something odd which is happening with the box. So that's what the generate dynamic alerts is. And then they also want to automate some of the, for example, RTBH kind of things. They want to monitor and sort of do prefix filtering, do some route optimizations, and lastly, BGP security. So all of this also feeds into BGP security with route leaks, hijacks, and such. I mean, this is just a very small subset. Like I said, there's way more which operators want to do. Okay, so let's see how BMP has tried to address some of these needs. So BMP is an IETF standard. Essentially, it allows us to export all the BGP related information, the control plane state in real time to controllers or servers wherever your BMP collectors are running. And then these are some foundational things which BMP has focused on in its evolution over the years. So one of the first things is BGP has been around since maybe last 3-4 decades. So it's pretty resource intensive, especially when it comes to high scale deployments, which is most of BGP deployments. And then since it's evolved over time, it's pretty extensible. So that is something which is built into BMP. that it is pretty flexible. And the second thing is, because BGP is resource intensive, the motive has been to have as little overhead as possible of BMP with BGP. And then essentially BMP is a tracing protocol. So it lets you see different things happening within BGP across its pipeline. You will see in a bit what the standardized pipeline definitions are, but that sort of is what the focus of BMP is. Then off late, there's a lot of interest in adding more and more metadata to these foundational pipeline elements, so which kind of helps with different use cases. So in a nutshell, using BMP network operators don't need to do CLI screen scraping anymore. I don't know if anybody still does it, but that's one of the things you don't need to do anymore. And one of the most common ways of sort of getting BGP feeds was having direct BGP peerings. We still see a lot of them using this because not every vendor supports BMP. So there's still a mix of people still peering directly with BGP in the good old way for their data collection. Yeah, so this is just a point to call out that it is not just BGP local RIP visibility. It goes beyond that. This is important. This is where your packet forwarding kind of happens. So it does become center of attention, but BMP is not just limiting us to just do this. It goes way beyond it. So you will see in the next slide that it helps us monitor everything coming into BGP, everything getting out of BGP, and then also what is getting programmed in the hardware. And there are also some drafts which are looking at giving you additional context of each of the BGP paths. So if a particular path is selected as a best path, why is it? Or if it was not selected, you know, the good old 12, 13 steps BGP best path selection, it will tell you exactly why a particular path chosen was not a best path. Yeah, okay. With that, let me dive into the different standardized pipeline phases of BMP. So it's broadly divided into three segments. The first one is your ADJ ribbon pre and post policy. So maybe before that, the way to view this block diagram is BGP updates are coming in from the left from all the peers, and then it goes through the best path selection, and then it gets out of the box to the right. And then these are the different phases in the BGP pipeline. And BMP has just standardized, has provided standardized ways into getting views for each of these sort of stages of the pipeline. So you see BMP servers at the bottom. Typically, the best practice is not to have more than 1 or 2 BMP servers talking to the routers. So any mirroring you want to do, it's usually better to do it off the box. So that way, router can do BGP, and then BMP doesn't get in its way. So one of the first phases is your ADJ ribbon pre-policy, that is before the inbound policy is applied. So one thing to note in BMP is it gives you all the paths. It is not a best path, but it tells you all the things which are coming in from the BGP peer in the ADJ ribbon pre-policy view. Then you apply the policy, maybe some of the prefixes get dropped, you add some attribute, you modify some attribute, and then what happens with it is provided in the ADJ ribbon post-policy view. Then it goes through the best path selection, and then it is your local RIP view, so you get a view into that as well. Then the same thing repeats on the outbound side. So there is ADJ RIP out, pre and post, before the outbound policy and after the outbound policy. This is sort of the foundation. I've called out the 3 RFCs, which may be from 2015 to 2020, try to standardize some of this, try to define the different message types, and exactly define how these things should be done from a vendor neutral point of view. Going a little bit more deeper into them. So one other thing is when you have a link to these slides, all of these link to the actual RFCs or drafts. So you should be able to click on them and be able to get more information for each of these RFCs or drafts. And then this is also, I'm just representing the entire working group here. So I've also called out the authors who actually worked on these drafts. And then you will also see in the next slide that there are some drafts which are working group documents, which means the working group has adopted and is working on them actively. But there are some which is proposed work. That essentially means that those are individual drafts, and it's currently not adopted by a working group yet. Okay, so on RFC 7854, this essentially defined the ADJ ribbon, like I called out in the previous slide, but it also called out and defined a few message types within BMP, which act as the foundation. So one of the ones which is used a lot is the route monitoring and route mirroring message. Route monitoring is essentially your BGP updates, and it is very similar to BGP updates because the updates are coalesced. Yesterday we were talking about MRI timer, so there is an MRI timer, and then every 10 seconds or 15 seconds, BMP sends the updates out, and that is termed as route monitoring. And then the other one is route mirroring. Not all the reviews support route mirroring. Route mirroring essentially is exact replication of all the BGP updates. Some operators prefer to use it because they do see all the error packets and such which come into the box, which cannot be supported through route mirroring. Then there are two other message types. One is the peer up. It tells you the peer's capabilities. One of the things within that, in addition to telling you that a certain BGP peer came up or down, it was also telling you that these are the peer's capabilities. So the entire BGP open message copy is there as a TLV in the peer up message. And the other counterpart of that is the peer down message. So the peer down message also lets you get a better perspective into why the peer went down. Is it because the remote side closed the connection, or is it because it's administratively down, or is it because somebody unconfigured monitoring that particular peer? So the route monitoring, route mirroring, peer up and peer down kind of become the foundation. And then I think in yesterday's Netflix presentation from Frederick and Ellis, they were talking about monitoring certain telemetry related statistics through from BGP. So some of that is already standardized and available in BMP across the views. So the statistics which are defined in BMP give you a view of, like what's the total table size in ADJ ribbon, what's the table size in like local rib or ADJ rib out, both in pre and post modes. And then it also gives you things like, how many prefixes were dropped because of policy or because of AS path, loop check, and things like that. So I think across these RFCs, there may be 20, 25 odd statistics which are defined. And then there is a new draft which is defining 20 or 25 more. So all in all, we have 50 of them. And then typically the way I've seen operators use this is as a first line of defense. They look at some of these statistics, and depending on what they call out, they double click and then go into the observability side of things. And then one call out on the local rib. So it is not just best path. It also gives you multi-path. And then I've seen people use local rib along with IPFix, kind of a data plane monitoring. So that way they can see what is BGP's view of multipath, what is BGP telling that it is downloaded to the rib versus what is the actual usage in the data path. So that's the standard use case I've seen. And lastly, the ADJ rib out. So one misconception is it's maybe similar to a local rib. But it is not. It kind of gives you a view from a peer point of view. So you may not send certain routes to eBGP or iBGP peers. So it gives you that view. And then it's not just by themselves. These reviews are monitored. We see operators monitoring, combining these views. So they sometimes monitor in pre and in post together, or out pre and out post together to do policy debugging. Or they have in post and local rib turned on in some cases. So depending on your choice and the use case, you can turn these modes on and off on the router. Now let's get to new functionalities. So the current version of BMP is V3. This particular draft has bumped up that version to V4 because there were some non-backward compatible things which were done in this draft. So the main motive of this draft is to solidify the foundation. I was talking about it earlier that it needs to be extensible. The route monitoring messages and the peer down messages were not TLVIs, so they were not extensible. So we couldn't address a lot of the use cases which the operators wanted. So you can think of this draft as a foundation for extensibility, which was not complete in the previous RFCs. And another thing which this draft is adding is support for enterprise specific TLVs. So this lets vendors experiment any new features and such without having to wait for full standardization. The main thing coming out of this draft, which a lot of the newer drafts have kind of built on, is the support for optional TLVs, and you will see that in a bit. So this is a working group document, so it's called out there. Then this one is the path marking draft, which gives you, like I was telling earlier, a better visibility into why a certain path is not chosen as best path. So if it is a backup, so it adds color to the paths. It tells you, it helps you to sort of figure out if this is best path, if it is back. For example, BMP in the in-pre or the in-post or in the local review will just send you all the paths, but there is no coloring of those paths. So this, using this particular draft, you will be now able to add more color, more metadata to those paths. So you'll be able to figure out, is this best, is this backup? If it is not, why it is not. Then one other thing which operators use a lot is timestamps to key into their time series databases. So what had happened over time is people interpreted, so there is timestamp today in BMP messages, but it was interpreted differently by different people. So some people used to put the trigger time in them, or some people used to put the time at which the updates were sent out from the box. So this was not standardized. So this timestamp draft is trying to standardize and call out that exactly what is the timestamp a particular vendor is sort of putting in these messages. Is it trigger time? Is it export time? Is it the local rip time? And there is flexibility to add all of this. I mean, it doesn't have to be just one. You can sort of send multiple of these. Then this is a new functionality where I was talking about alerts earlier. So the route event logging draft is trying to cover anything specific to routes, and the generic message draft is trying to cover anything not covered by the route event logging. So these could be things like send alerts for policy discards, validation failures. The generic message draft, for example, if you unmonitor a specific mode on the router, today the BMP collector has no way of knowing if a certain review is no longer monitored. So it has stale routes and paths. So this kind of defines a way to invalidate that cache on the collectors. All right. Then some of the operators came by and they said, whatever current functionality we have with route monitoring and other things is not suitable for us to synchronize with the routers, either with the routers, or they have this notion of BMP online collectors and BMP offline collectors. Apparently, not all the collectors are connected to the router all the time. They have some collectors which just come up periodically and then they sync. So they store all their data in like bins, MRT and such. So there was a need, and there was a gap they saw, where they said the current way of synchronizing with the router doesn't meet their needs. So they have defined this particular draft, which is trying to define synchronization mechanisms midstream, which is not possible today with other mechanisms. And the statistics draft, so there's 20 more statistics which got added through this particular draft. So it's building on the total number of routes and paths in a table and all the errors and all such counters. There's a lot of interest from operators in statistics. I see there's one more draft which has come up, which is defining AFI-SAFI specific statistics like for EVPN and such. Monitoring BGP at high scale, it could potentially impact performance of BGP. So we are also looking at ways in improving the performance and convergence more from a message encoding point of view. So we have these 3 drafts which are currently looking at how do you optimize the encoding itself. So this translates into less CPU cycles on the router, less CPU cycles on the collector. and then overall better convergence time. So if BMP takes less time, then it gives more time for BGP. So it's a win-win overall. So the route monitoring aggregation draft is trying to aggregate multiple route mon messages across different peers in a given review. So if you have a certain review, if you're one thing I just want to call out again is in BMP, all the update messages are per peer. Unlike BGP, which can be across peers, here there's a peer header, so everything gets grouped within a peer basis. So here, this draft is trying to aggregate that so that we can reduce the load on the box. The route monitoring common updates is trying to aggregate things across reviews. So if your policy is not changing much of the data between, let's say, out pre and out post, let's say only 10% of the things are changed, then you would unnecessarily send almost 1.8x data to your collector. So you can optimize that by combining things across views. The multi-peer header draft is kind of the foundation for the route monitoring aggregation draft. We are looking at what other message types can be aggregated within BMP. But for now, the first use case is route monitoring. Then there is the manageability draft which defines the Yang model for configuring BMP itself. So it goes into great detail into how can you granularly enable monitoring on the router. So it helps you define things like which particular neighbor, what particular review do you want to monitor, what AFI-SAFI filters do you want, what kind of TCP options do you want to configure, in all of that. So there's also a little bit of operational data which is mentioned in this, but mostly a lot of it is configuration based. These are some new and upcoming areas. So the original BMP RFC recommends using IPsec, but this particular draft suggests using TCP/AO as an alternative. It's not a replacement because you're not getting end-to-end security with it, but it's an option. Then there is discussion around having BMP over QUIC. Today BMP operates over TCP. So this draft is proposing using QUIC as an alternative. So it gives us two benefits. There's multi-stream support in QUIC. So we can sort of use that in BMP and avoid head of line blocking across BMP messages. Like if you have too many updates going out and then you have a peer down sitting behind them, so there is HOL for that. So we're using streams, you can kind of design it in a way where that doesn't happen. And then there is built-in TLS support, which comes free with it. Then there is a recent draft, which is just a proposal to use BMP monitoring for RPKI. I just put it out here so that, it's not even a solution. So when things come to IETF, it doesn't have to be a solution. It can be just a problem statement, which can be put forth to the working group. And if there is enough interest, then like-minded people get together and then they start solving the problem. So this is one such draft. We have quite a few examples of such drafts. So this is just a proposal of why it is important to monitor RPKI as well with BMP. So this is in fairly early discussions. So this is sort of just a snapshot of what's going on in the IETF world. There is maybe 10 more drafts which I haven't listed here. And then before I end, this particular slide is a snapshot from Swisscom's DAISY network analytics platform. Here, Thomas tried to showcase sort of updates which are going across their network. He was telling us that it's maybe like 30 to 40,000 nodes. Here he has applied a filter for a specific standardized community for a specific RD. And then he wanted to sort of see what the updates and withdrawals look like and for what set of next hops. So you will see on the right that there is BGP next hop listed. And then you will see that those are the next hops where the max churn happened in that sorted order. And then this is sort of a time graph where your y-axis is your number of updates and withdraws, and your x-axis is the timeline. I think the unit is a minute or such. So this is all the time we had for today. So we just added one slide, but if there is enough interest, we can come back and talk more about what sort of use cases has been solved with using platforms like this. Okay, so that was my last slide. And then essentially we want to have your challenges drive the protocol. So please join us at IETF, and if you think we are missing some use cases or we are not solving certain problems, we would love to hear from you, because more operators join us at IETF, then better would be the standardization of the draft. So there's no IETF experience required. Like I said, we see people without solutions also approaching us with use cases. So these are just some references of how to connect going forward. The mailer, the homepage, and then our chair and the area director as well. So this QR code also gives you, takes you to that homepage. Okay, I think we have about 4 minutes for questions.